All right, so we had a little bit of a hiccup again, and I had to like stop the recording, and I apologize. But what I demonstrated in the interim when we dropped out is I couldn't directly here create a blank array like this and then try to put stuff in it. It doesn't really throw an error, you notice, right? But when I run it, it gives me a runtime error, right? Which is an exception because I'm declaring a blank array which has no positions. So what business do I have putting stuff into position 0 and 1 that don't exist, right? And the the fix for that is to do this approach and then put inside the square brackets on the right side, you say new integer array of size 12, right? So now I have one with 12 positions that I could populate all of them. All right, so I'm just showing you all the different kind of approaches to this, but I'm going to go with my hard-coded array on this, right? So now that we have that piece in place, and hopefully we don't get any more internet dropouts or weirdness going on, so I apologize for that, but these are all basically demos. This one statement creates the array and puts stuff inside of it. So this is a really good approach, right? I think, right? These are all little demos, but I'm going to keep them in place in case you want to experiment with them, please do, right? There's no better way to figure out how a technology works than to tinker with it, really. All right. One thing that you also discover is that when you're working with array structures, because they are structured and the objects inside the array are ordered by the index values, they're very traversable using loops. So I can, for example, set up a loop like this. I'm setting up a for loop, and I'm going to run the loop as long as the numbers array dot length, up to the length of the array, basically. And then we're going to increment our counter once each time for every iteration. Now I can do my system.out. I'm not doing a print line here, just a print because I want them to print on the same line. I will traverse the structure using the index value, which will increment automatically up until the length. So we'll just cover the whole thing. And then in between each character, I'll put a space, maybe even 2 spaces, make it like amply look good. All right, let's see if this works, right? This is a way to take the array of integers and put it on the screen. All right, so here comes the run. And I want you to think back to the first time I ran it and I just put numbers in there without any index values, and it gave me some like really strange looking stuff, which is like, I think they're basically like memory pointers or something is what they are. They're like references in memory to where it's stored, not what's inside of it. Right? And that's an important takeaway. So there's the thing. And isn't it one of the directives here to print it out in order in which they're in the array? There you go. There's step 1. Pretty simple, actually, right? Right. I'm going to move on then, and I'm going to put here after this a system.out.println to get a blank line and move this down 1. Now I'm going to run another loop, but this time I'm going to reverse the order of it. So I'm going to start my loop control variable. I'll use I again, doesn't matter. And instead of starting at 0, I'm going to start at the numbers dot length minus 1, right? Because the length will always be, and I'm going to truncate this a little bit. So I'm going to go numbers dot length minus 1, because the last position will always be 1 less than the length. Right? Because we're going in reverse order, I'm not going to go I less than or equal to. I'm going to go I greater than or equal to 0. So it's going to run until we hit the 0 position, and then we want to stop. Right? We don't want to include it. And instead of doing an increment each time, we will do a decrement. So we'll do I minus minus. Here comes the curlies, right? And then basically the output is going to be the same as the output we had up here. Same exact thing. Right? It's just traversing it backwards. And so let's see if this works. Right? Saving. There comes the run. Is it reversed? Sure looks like it. So we were able to create an integer array. We were also able to play with a couple different ways to create it and put stuff into it. We also noticed that there's a length property that goes with arrays. Notice there's no parentheses on this one though, right? But arrays have that feature too, because sometimes it's very useful to know how long is your array. You know, how long am I going to iterate over it to get the contents in and out? We hard coded this one up at the top. We were able to traverse it in order and then traverse it in reverse order. So this is the first exercise. Let's move on to the second exercise. Hopefully that, you know, maybe this will just be the recording and the other recordings will be thrown away, I'm thinking. Let's go to the next exercise description. So I think, if I remember right, we're doing exercise 1, 2, and 6. Exercise 2 is allow a user to enter any number of double values up to 20, right? So we're going to need basically an array of size 20. This time, this one will hold doubles instead of integers. The user should enter 99999 to quit entering numbers, and then display an error message if the user quits without entering any numbers. Otherwise, display each entered value and its distance from the average. Okay, a lot taller order on this one. So let's start digging in to doing it. All right, let's start by going back to Eclipse, starting a new program. So I'm going to right click, new class. We're going to call this distance from average. Public static void main on that. We are going to be prompting our user. So the very first thing I'm going to add here is I'm just going to drop in a scanner right away. I just want to get that out of the way. Control space to add the library. We'll call it input as we normally do. And then we'll initiate the new scanner object. System in to capture stuff from the keyboard and a semicolon. All right. Now we want to declare an array of up to 20 values. All right. So I'm going to, and we're going to store doubles, right? So like floating point numbers, basically. So double square brackets shows we're building an array of doubles. I'm going to call it numbers again, just easy to, you know, good choice for it. And then because I know the specific size I want, I can say new double, and then inside here, the number of positions. Now, I'm going to be real practical here. I don't want to sit here and type 20 numbers, so I'm going to lower this number down to 10, right? But you should make yours 20, right, and test it that way. You know, it's good for the soul, all right? Now, as people are entering numbers, we're being asked to calculate the distance from the average. When you calculate averages, you need to be able to store values, right? So we have to be able to take all the numbers, total them together, divide by the number of entries, and then come up with an average. So we're going to be storing a couple different things. The first thing we're going to store is the total that we're going to try to average. I'm going to start it at 0, though. We're going to do another double. That'll hold the average itself, so we can display it on the screen. That will also start at 0. All right. The other thing that I read in the instructions is we're going to prompt the user to keep entering numbers until they type some magic key sequence that will break us out. And the thing that we're looking for is 999, right? But I'm going to create a value called entry. I'm making it a double. So the number that they're asking for is an integer, but I'm going to put it in the form of a double because otherwise we're entering doubles. I just want to use one piece of logic and not multiple pieces of logic to make this happen. I'm going to leave that blank. That will be initialized elsewhere. Another thing that we're going to do is we're going to be entering values. And as we're entering each value, we're going to grab that value and then put it into the array. And I need a temporary spot for that. And actually, that's not what we're going to use that for. And I'm just like thinking out loud here. What I need actually is not the temporary spot where we're grabbing it. That's going to go in entry, right? So entry is going to share like the exit code and whatever we capture. What I'm looking for is something that's going to count for us. That can be an integer. I'm just going to call that X, and I'm going to preset that to 0. So there's all our variables. Now we're going to do our prompt. I am going to copy paste this in for the sake of speed here. It's a pretty simple prompt. So we're going to prompt the user and say, and I'm going to do a, well, I'm doing a print line, I guess, but I probably better do print. And I'm going to say enter a numeric value or 999 to quit. I didn't do 5 nines. I'm doing 4 nines. Now, now we're going to go into a while loop, and the while loop is going to handle most of the rest of the mechanics here, including the logic that will allow it to keep running. So one thing that we're looking for, as long as the entry that they put in does not equal 999, 4 nines, and as long as our count is less than numbers, let's see if I can type it, dot length, right? Because we can only go as long as the structure is. We will keep running this loop. If we fill the whole loop, then we're done anyhow, right? So if we reach 20, basically, in my case, 10. Right? Every time through the loop, we're going to take whatever the current position is that we're traversing. It starts at 0. And we're going to take whatever the entry is and store it in that position. So the entry will get captured and put in the given array position. Right? Now, as we're doing that, there's no time like the present to start building the average. So I'm going to start adding whatever was just entered. So I'm going to plus equals numbers x, the current value, into the total so we can average it. Our counter will get incremented by 1. And so x will increase so that we can eventually get out of this loop. And then we're also going to check, basically, if x is still less than numbers dot length, in other words, it's not filled yet, then we're going to proceed and prompt, curly brackets here, we're going to prompt the user to re-enter a number. So here comes the prompt. I can just use the same one that I have above, the same exact thing. And I'm putting print lines in here, but I'm switching them to prints. I think that will probably work better. I may be wrong. Maybe I'll switch it back. All right. So this will keep running, keep prompting until we either fill the array or they type 999 to quit. All right. What if we get the snarky user, because this is possible, right? And they enter nothing. So if x is equivalent to 0 after this while loop, then we're going to trigger an error message, right? And the error message might look something like this. This is a copy paste, right? Error, you did not enter any numbers, calculations cannot be performed, et cetera, et cetera. And we can put in an else here. If they did enter values, now we're going to calculate the average. So we'll take the variable that we created, average, and we'll do the math. So we'll take the total, we'll divide it by whatever total number of things we have, which will be represented by x because we were counting the whole time. So there's the average. And then I'm going to system out print line the following. And I'm just thinking here, might not be a bad idea to do a system.out.println here, just in case the one above doesn't like moving down to the next line. You guys are feeling what I'm saying, right? And actually, probably put one here too. I don't know if that's necessary. I will find out as we're running it. All right, not a big worry. All right. Is there anything else we have to do here? Well, if I remember the directions correctly, we also have to not only display the average, right? And it says you entered X numbers and their average is whatever the average is. We also have to show for each one of those numbers how far it is away from the average that we calculated, right? And that sounds like a loop to me. So here comes the loop. For int I equals 0. So we'll start at position 0. And as long as I is less than X, the total number of items in there, we will increment each time through the loop, and we will do the following. We will basically do this statement. Yes, I'm copy pasting in for the sake of speed because class is technically over. We're going to output what the number is. We're going to take the number and subtract the average, and it's going to give us either a positive or negative value. So how far away we are from the average and in which direction, right? And that, folks, is the code. So there's the entirety of it. So here's the top part of the code up through the while loop and the bottom part of the code to finish off. All right, I'm going to go ahead and pull up the console here and give this a run. Probably prompt me to save because I don't think I did. All right, enter a numeric value or 999 to quit. Well, how about I just don't put in anything? It sure doesn't like that. All right, so I put in a string and it really failed. Okay, not very good so far. All right, probably need some exception handling or a way to absorb that. All right, how about I just type 0? Okay, it's still prompting me. I'm typing. I'm going to type 999 to quit. How many nines do I need? 4 of them. All right, there it is. So you entered 7 numbers and their average is whatever. Right? That could be formatted. And then 0 is, yes, that far away from the average. That makes sense. That makes sense. That makes sense. Right. And then you see the results. Now, I am going to stop the execution of this here. We could always revisit this next week. I think there's still a couple little issues and problems here, but you know what? Not a big deal. Generally, it's working. When we come back together next week, we'll do the other exercise, but this video will end here.